All right, in this next example, we are going to be solving a system of equations in three variables. Three equations, three variables, and we're going to be using elimination. We'll try and combine some things together we're trying to cancel a variable out, and it doesn't really matter which one you choose, but you're going to have to do it twice. So you have to have kind of a little bit of a forward thinking on this. So we're looking to maybe cancel let's say the z's. The z's seem somewhat reasonable. Like these two will go away pretty easily without doing anything, and then maybe we can manipulate the middle one to combine with this thing. All right, so let's start with, let's do that. Let's combine this. Let's make this a 3. So we'll multiply that by 3. And so we have a 2x plus y minus 3z equals 1. And then the second equation got multiplied by 3, so we got a 3x minus 12y plus 3z equaling 18. We'll combine everything. Our z's go away, which is what we were intending. You got a 5x minus 11y equaling 19. All right, and then we'll put these two equations together. So if we put those two equations together, we have x minus 4y plus z equals 6. We have 4x minus 7y minus z equals 13. And z's go away. So we combine all this stuff, and this gets us a 5x minus 11y equaling 19. So just like in a prior problem, once you get to this point, you're going to now pull these two equations together and almost start over. You got two equations with two variables, so we'll do elimination again. We'll do that same feel here. So we have 5x minus 11y equaling 19. We'll pull this one over. You have 5x minus 11y equaling 19. So let's say we want to cancel your x's, so we multiply a negative to this thing. So if you multiply a negative to this, you're going to change all their signs. So that's going to become a negative, that'll become a positive, that'll become a negative. And you're actually going to cancel everything. So you're going to get a 0 equals a 0. So that is an infinite solutions. But there's definitely going to be more to this. So we're going to talk more about this. We're going to use matrices to help with this. Because again, there's a visual potentially to this that, if we go back to this first one, that if you're solving a system of equations with three variables, three equations, they're not lines because they're three-dimensional now, so they're surfaces. So this is actually a flat surface because it's like a linear. So you have a flat surface, like a wall. So you have three of them, and you're trying to see where they all meet. So I think of it like a corner of a room. You got two walls and the ceiling. Those are all flat surfaces, and where do they meet? They meet in a corner, and that point represents that corner. So in our second situation, we had no solution, which basically meant the three lines didn't meet all at one spot. Well, our last situation is infinite solutions. So actually all three of these planes meet, but when they meet, they form a line. So it's like taking, I don't have a good example, your wall and ceiling and having another angled wall going through and making the whole line basically of where the two things meet. So it's like having a line where they meet, and then you have a third one that cuts through the exact same spot. So we're going to have an infinite solutions, but we're going to have to create something fancier with our coordinate. So we're going to have something like this, but it's definitely going to be far more complicated than that. So we're going to use matrices to help finish this. All right, but right now it's infinite solutions. There's going to be more to it. All right, and we'll get that on a future video when we do matrices. So we can solve all this stuff with matrices, and so we'll talk more when we get to that.